going to start. Hey guys, today I'm going to start a new playlist about data structure and algorithms for third sem students, and this this will be the last moment, the last moment study about this whole things like what is data structures and algorithms. If you don't know anything about data structure and algorithm, and if you are a MAKAUT student, so for passing your semester examination, this will be very beneficial for you. So in this playlist, we will be going to cover uh, some basic topics about data structure, and those are the some deleting or inserting some nodes in tree data structure. We will be again solving some questions about BBA for BBA question papers or BCA question papers. The algorithm to reverse single linked list and to insert a node at any position of a circular linked list, delete a node from any position, about some asymptotic notations like for big omega notation, theta notation, and big O notation. We will be going to study a little about time complexity of binary search, or if any recurrence relation is given, we have to find out the time complexity, and the stack ADT, or you can say the push pop operations in stack, in queue DQ operations in circular queue or any normal queue, or priority queue, row measure, column measure types math, and some static and dynamic memory allocation problems, or what's the difference between calloc and malloc. Like this whole thing will be in our uh, playlist. These are the basic things. If you want to pass your MAKAUT examination, this will be our basic things. You have to cover all of these topics. This is the main thing. You have to cover all of these topics like bubble shot, quick shot, merge shot, selection shot, heap shot, and the basic need like you have to know the time complexity of these all sorts. If you don't know how to just how to you know how to find out the time complexity of these sorting algorithms, then it will not be a very big major problem. But you have to know, you have to go through that uh, dynamic and static memory allocation, also recursion, and what is the difference between tail recursion and non-tail recursion, etc. So first of all, we will be going to study about prefix and infix expression. So what is prefix expression? Prefix mean where these expressions, these are the operator. These operators are at the first position. Before these operands, when the operators are presented before the operands, then this type of expressions are called prefix expression. Some questions come oftenly that transfer this prefix expression into a infix form. Infix means when this operator will be in the middle of those operands. Like here, the operands are A, B, and C, and the operators are a multiplication operator, addition operator, division operator, and here it is subtraction operator. So when these operators will be in the middle of those operands, then it will be called infix expression. And when these operators will be in front of the operands, then it will be called prefix in expression. When these operators will be, uh, this side, like at the end of the operands, then it will be called postfix expression. So the first step or the algorithm is reverse reverse the whole expression. You know, this is our given infix expression. So we have to reverse this whole expression. So from here we have to start writing. So L will be at first, then D will be, then A, and then this operator, that is division operator, then this minus operator, then C operator, then B operator, like this. So and the next step is to solve. The formula for solving this problem is operand 1, then operand operator, then operand 2. Operand 1, operator, then operand 2. So we have draw a stack here, and we all know that stack follows LIFO principle. LIFO means last in, first out principle. So at the last point, what element will be presented will be, popped out at first. Last in, first out. So here uh, A came at the last, so it will be popped first. We will go in depth. Just wait and watch. So here the first is L. We had made a stack and L is first position. So we will be push L here. We had push L here. Then it is D. So we pushed D here. Until and unless any operator came, we had we had to push inside this stack. We had to push operands like A, D, L inside the stack. We should keep pushing these operands inside the stack until any until we found any operand. Okay. So here L is the operand until we found any operator. So L is the operand. We pushed L. Then D is the operand. We also pushed D. Then A is the operand. We also pushed A. Now we encountered a operator, that is division operator. So now we have to pop out. When we when will we encounter any operator, then we have to pop out. And according to this formula, we have to pop out. And the uh, numbering step will be 1, 2, 3 like this, and we have to pop out. So operand 1, this is the first thing we should pop out because stack follows LIFO principle. So A popped out, and then the operator. So we encounter this division operator. So we have written this division operator, and then we have to pop the operand 2. So the operand 2 is D. That means the next operand. So we have to pop this D, and now this D. So this is our current or ultimate state, A divided by D. So we have popped this thing out, and this is our current thing. So now we have to push this inside this stack. This is this whole thing is completed. Now we again made a stack 2, and here L, we did nothing with this L operand, so it is presented here as before. And our current thing, that is A by D, we pushed it here. Now again we again encountered operator, that is minus operator or subtractor operator. Then we have to pop again. We have to perform the pop operation again. So the operand 1, that is this is the operand 1. We should pop this as it is on as it is on the top. So we have to pop this. So A divided by D. And here then we have to write the operator. We encounter this minus operator, so we write this minus operator and then this L, because we have to then we then have to write the operands too. So this is L. So this is our current state, and we push in this stack 3. This is our current state. And now we encounter a operand, that is C. So we pushed C in this stack 3. Then we encountered B. We pushed this in the stack, and then we found this slash operator, that is divided operator or slash operator. Then we have to again pop, and according to the formula, operand 1 should be popped out. So B is popped out, then operator, we encountered these operators, so slash and operand 2, that is C. So this is our current state. And before this, it is it was already presented in the stack, so it will be remaining as the same. And this new current state will be pushing inside the stack. And after that, we encountered a operand, that is A. So we'll be pushing inside this stack. Here it is A. And after that, it will be again popped out because we will be encountered a operator, that is plus operator. So after popping this out, uh, this is the operand 1 and operator, that is plus, and then B divided by C. So like this, our ultimate infix expression will be this. Likewise, for performing prefix to postfix expression, the formula is operand 1, then operand 2, then operator. I think you are finding out the similarity between these two. Like here, when we have to find out the infix expression, then the operator will be between the operand 1 and operand 2. That means inside, infix means inside, and here the operator is inside the operand 1 and operand 2. And when it is postfix, that means the operator is at the end of the operand 1 and operand 2. Exactly the same process uh, will be here. Like the expression is given, you have to do the reverse first, then you have to solve this, like exactly like we did the same before in this case. So I'm not going to just explain this again. If you try to understand uh, our previous example, then it will be much more easier for you to solve this. So like this type of question often comes in MAKAUT examinations, like evaluation of postfix expression, when this type of expression is given. Evaluation of postfix expression means our given question is infix. You can see here these operands are inside this operator are inside these operands. So this is the infix expression, and we have to transfer this infix expression to postfix expression using stack. You can see here this is my personal notes, and you can solve it by yourself. This is also an example. This is also a very very important examples for your MAKAUT exam purpose or any competitive exam purpose also. Now, for transforming postfix expression to prefix, the formula is operator, operand 2, and operand 1. You just have to remind this formula, and then these expressions will be automatically solved. But one thing you should remember for postfix to prefix transformation, that we don't have to reverse. We do not have to reverse this expression like we had to do for for postfix, like these cases for prefix to postfix or prefix to infix. We do not have to do the reverse. We do not have to do the reverse operation for postfix to prefix case. We just only have to remind this formula, and we have to just start solving it. The formula for solving postfix to infix is a sorry operand 2 plus operator and operand 1. One thing you should remember, that is, for solving infix to prefix expression, the algorithm that follows is, uh, first we have to reverse the expression, then we have to postfix the expression, then again we have to reverse the expression. This is the most important thing for infix to prefix expression conversion. For infix to prefix expression conversion, the most important, and you have to remember this thing, that is the algorithm is, you have to reverse the expression first, then you have to do the postfix conversion operation, and then you have to again reverse the expression. And here one thing comes, that is precedence level. When the factorial, or here this is to the power sign, when the factorial or to the power sign come, their precedence level is the high. And when these operators come like multiplication and operator and division operator come, their precedence level is second, and the lowest precedence level are minus, plus, or this division operator. Sorry, this or operator. So, for example, this is our expression, infix expression given, and we have to do the infix to prefix conversion. So this is our infix expression given, and as per the algorithm, we have to we have to reverse the expression. So this this is the bracket, this is like this bracket, so we have to do like this. Then L, then minus, then K, then slash, then A, then this type of bracket. We have to do this type of bracket. So here it is multiplication, then this type of bracket here. So we have to this type of bracket. So we have to do this type of bracket. Okay. And one note we should remember, that is, no two same operator of same priority can stay together. Okay. I'm not going to explain this because I'm going to explain the next example, that will be very easier for me to explain though. And you know you can just take a screenshot of this question, and you can try to solve it by yourself after I explain to you that how to solve it. I'm going to explain this example to you. So the problem is a plus b multiply bracket c to the power d minus e bracket to the power f plus g into h minus I. So I have already written the precedence level, and here to the power is the highest precedence level, and multiplication and division is the second, and minus plus is the lowest precedence level. So here this is the first, and sorry, and here it is infix to postfix conversion. For infix to postfix conversion, we don't have to reverse it. For infix to prefix conversion, we have to reverse it. So this is the symbol column, and here A is the first operand. So we push in this stack, or you can say in this column we push A, and for operator stack we push. Sorry, we have to push this column in symbol stack also, and operator stack also, because it this is an operator. So the plus came and we push it here, also it here, and in postfix form we pushed A here. We will not push any operator here. We will be until there are until we meet the condition. Then B come, and B straightly goes here, because in this operator stack only operators will be stored. And then multiplication came. Here multiplication was there, then multiplication came, and plus and multiplication stays together. Then this bracket came, and this bracket goes here, and then this C came and this C goes here. Then this this to the power operator came, and as here it is there is a bracket, so there's no need to go the to the power to here in this case. When this minus came, then the precedence level condition break. Like when this minus came, this is the lowest precedence level, so we should keep the lowest precedence level before the highest precedence level uh, operators. So the minus is the lowest precedence level operator, so it should be kept before the highest precedence level operator. So this to the power sign should be here after this minus. But you can say here the minus is after this to the power sign, so this to the power sign will be uh, popped out from this operator stack and will be goes to this postfix expression column, and then this E came and straightly goes here, then this bracket came, then this bracket came, and this bracket goes here as it is an operator, and as the bracket closes, the operators, those operators are present inside this bracket will be popped out. So here minus operator is present inside this bracket, so it will be popped out from this stack and goes straightly here. And then this operator came again. So this will be easily can stay here, because this is the lowest priority. You can see plus is the lowest priority, and then multiplication, then multiplication, and then this to the power operator, so it can be stayed here without any um, without any problem. So that's okay. Now this operator came and stay here, then I have came and straightly goes here, then positive operator or plus operator came and stay here, then z came and go here, and also this multiplication operator comes and stay here, because it is not breaking any rules. Like the only rules is there, the that is this that this should be according to the precedence level. The lowest precedence level will be kept at the first, then the middle precedence level, and then the highest precedence level. And if there is a brackets present, then that's okay. There will not be any problem if there is a bracket. So as here is a brackets present, so after this to the power or the highest precedency, we can write this. We can keep this plus operator here like this. Uh, all the operator comes and the operands goes here straightly. And here you can see the again this plus and multiplication operator came. You know, multiplication operator has the highest precedence level than this plus operator, this addition operator. So this is the first and this is the second, and also the bracket is closed. Also the bracket is closed. So we have to pop out, and this came first and this came second. So um, we have to pop out. Oh, sorry, this came first and this came second. And as this is a step, as per the LIFO principle, we have to pop out this multiplication operator. We have to pop out this multiplication operator first, and then we have to pop out this plus operator or addition operator. I think you are getting my point. This came first and this came last. This positive operator came first. This multiplication operator came last. And as per the stack LIFO principle, last in will be first out. So this the multiplication came last, so it will be popped out first. So here it is popped first, and then this positive operator came, so it will be popped out after that. According to this, according these principles and also like the formulas of the solving this type of problem, so this all will be cancelled out. So this will be cancelled out first, and after that, when okay, I need to explain this again with more details. When this minus operator came, when this subtraction operator came, it has the lowest precedency level. So we have to pop out all these because these to the power operator has the highest precedence level. So we need to pop this out first. So it is popped out. Then compare this multiplication operator to this minus operator. So this multiplication operator has the highest precedence level. So we need to pop out also, and then this positive operator, this positive and this minus or subtractor operator both have the same precedence level, so it cannot stay together, so it will also be popped out. And after that this I will came, and in the stack this minus will be only presented in the stack. After that this I will came, and will go straight to the postfix column, and then this I will be popped out. So this will be our ultimate postfix expression from this infix expression. So this will be our ultimate conversion. You can take a screenshot here. You can solve this type of problems also. I'm sorry. Here a question came. Evaluate postfix expression of this expression using stack. So the above expression is the infix expression. So first of all, we need to convert the infix expression to postfix expression, and then we have to evaluate the stack. This is the whole process. You can stop and you can do it by yourself. And there very important important portion comes, that is row measure and column measure calculation, address calculation in row measure and column measure. And the formula is this. This is the formula. So, like if you are having a matrix, like this is the row number, these two are the row numbers, 0 and 1, two rows that is represented by m, and three columns that is 1, 0, 1, 2, that is three columns represented by n. Then we have to find out, suppose we have to find out that 1 or 0 position, what is the address, or what is the address for this according to row measure. So according to row measure or formula, at 1 0 position, at 1 0 means 1 0 position, and so the base address will be given to you. Like for this case, suppose the base address is 200 and I into n, I into n. I will also be given to you. I is 1 here. I into n. N is the number of columns plus j. J will also be given to you. And the size. Size means for integer number, it is varies from 2 or 4 bytes depending on the data type and the platform. Um, for int, it is 2 to 4 byte, and for signed unsigned number, it also varies 4 bytes. For character, it is 1 byte. For float data type, it is 4 bytes. For double, the size is 8 bytes. Sometimes the size is given to you while asking the problem, and but sometimes you have to remember these sizes by yourself while solving this problem, this type of row measure, column measure problems. And the column measure formula is this: the base address plus this j into m, that is row number, plus I into size. Wait a minute, we will be uh, explaining this in very detail. Suppose this type of question has came into your exam paper. That is, consider the following declaration of a two-dimensional matrix: character A 25, 90, 50, 80, and starting addresses 50. The calculate the address of a 49, 61 with respect to column measure and row measure. So here this matrix is two-dimensional matrix. This matrix is two-dimensional matrix. It is declared here in the question. And this is the lower boundary. This 25 is the lower boundary. 90 is the upper boundary for row. For row, 25 is the lower boundary, 90 is the upper boundary, and for column, 50 is the lower boundary and 80 is the upper boundary. The formula for calculating the row measure is this: Aij, base address plus size of each element multiplied by n, capital N, I minus LR, lower boundary, plus j minus LC. This is the lower boundary. This is the for the row, and this is the lower boundary for column. This is the formula. You have to remember it while solving this type of questions in the essay, where LR is the lower index of row and LC is the lower index of column. Let me just zoom in some uh, more. And the row measure. This is the character type data. That's why the size of each element is 1 byte. It is given here that character A. You have to study the question very much. You have to read the question very carefully, uh, because sometimes the size will be given, but sometimes the size will not be given. Like for this question, the size is not given. So according to the question, you have to find out that which particular size you should use. For integer, it will be different. For float, it will be different, and for character, it is 1 byte. So, and m is 66. M will be calculated like this: 90 minus 50. 90 minus 50, 20, sorry, 25. 90 minus 25 plus 1. M is the number of rows. We already knew M is the number of rows. So here, for two-dimensional array, there is two part, that the one is lower bound and another is upper bound. So upper bound minus lower bound plus 1 is equal to the number of rows, and upper bound minus lower bound. Upper bound minus lower bound plus 1 is equal to the number of rows and the number of columns. So for the number of rows, 90 minus 25 plus 1, and for the number of columns, 80 minus 50 plus 1. And B is the base address that is already given inside the question. Sorry. According to the row measure formula, so according to the row measure, and this 4961 is also given in our question. You have to find out the base address, calculate the address for A, 49 and 61 with respect of column measure and row measure. So for the column measure, we put this formula. This is we have to find this out, and by putting this formula, all these uh, all this information is in the formula. We are getting 1255 for the row measure. This is the base address after by calculating row measure, and for by calculating through column measure, we will be getting 1250 the base address. So take a screenshot here from here. This is the another problem of row measure, column measure. This is also a very important problem for row measure, column measure in data structure and algorithm. Sorry. This type of tricky questions also came in question papers, like more time, like you know, competitive exams and also MAKAUT questions. Uh, the question is: consider the following stack of characters where stack is allocated. N is equal to 8 memory cells. Stack A, C, D, F, K, comma, dash, dash, dash. So the operation that take place, those are pop stack, comma, item. So this is our stack, and where N is equal to 8 the memory cells. This is our stack A, and A, C, D, F, A, C, D, F, K. Those are presents, and these 8 and these 3 are void. So from these 8 cells, 3 are void. So pop. Now we have to perform the pop operation. So what that is pushed at the last will be popped first according to the stack rule. So the K will be popped out. Then we have to perform again the pop operation. So this F is in the current top position. This F is in the top position. So whatever the element, which element is at the top position will be popped. So F is popped. Then we have to perform the push operation. Push stack L. So we have to push L inside the stack. So after this, after popping this F, the top is D and we are pushing L here. Then we have to push again P. So we pushed P here. Then we have to pop. So P will be popped out. Then we have to pop. Then we have to push R. So R is pushed here. Then we have to push S. So S is here pushed, and then we have to pop the item. So these R will be oh sorry R will be here, S will be popped up. So this is our ultimate stack condition. So A, C, D, or R are the ultimate stack conditions, and these three are the while. So top is equal to 4. 1, 2, 3, 4. 1, 2, 3, 4. And the topmost position, which element is present? R. So now, if again if again I condition is given, pop, then we have to pop this R out. So this will be our ultimate answer. Look how easy this is. But this much big question can confuse your mind very easily, that you will stop yourself from doing this, and you will eventually just ignore this type of big questions. But this is the easiest ever. Coming to the next question. This is for Q. We know that Q is Q follows the FIFO principle. FIFO means first in, first out. First in, first out means which will be pushed first will be popped first also. According to the LIFO principle, that stack follows the LIFO principle. LIFO principle is last in, first out. Last in, last out. Sorry, last in, last out. And FIFO is first in, first out. So here, this is the front condition. At first, when the queue is void, when the queue is just started, then uh, at this position, F and R. F is front and rear points. These are the two pointers, front and rear. These points at the first position, that zeroth index. These two follow points at zeroth index. So front is equal to 1. So that means, and rear is equal to 2. That means 0, 1, 2. Here the front is present. Here the rear pointer is present. Dash P Q. Develop the following operations on R. R is added to the queue. Delete is to be added to the. We can add any elements inside the queue through this rear pointer. You should remember there are some rules for use, and also there are some rules for stack also. We will be studying that later, but for this particular question we need to know that from rear pointer, we include we insert any element, and from this front side we declude any element. There is a term for queue, that is dequeue. Dequeue means delete, and there is a term that is enqueue. Enqueue means insertion. So, uh, at first our queue is like this. First position is void, or that means zeroth index is void. Then P and Q, and sorry, then two positions are void. So, and first and second index, only P and Q, these two elements are present. And here the front pointer is at one position, and at the second index the rear pointer is there. So now we have to perform the operation. R is added to the queue. From this rear position we can add any elements. So this rear position will be increased by 1, and in this position we can add R. So here you can see the R is increased by 1. So R is now at the third index. That means here, that means here. So here we can insert R. Then delete operation is performed. We can delete through this front side of the queue. So now P is deleted. So F is increased by 1. F is equal to F plus 1. That means F is at 2 position. F is at 2 position. And then these elements is deleted. This P is deleted. Now S is inserted. S is added to the queue. That means R will be increased. R will be increased. Here, after the deletion of P, this is the our current queue, where Q and R are present. Add edge. That means rear share will be increased by 1. That means rear is at 3. So it will be at fourth position. So at fourth index, the X S element will be added. Then T. So suppose this is a circular queue. Sorry. This is given that this is a circular array. This is a circular queue. So now from this the R will go to here. So while inserting this T, the R will be going to here. At the first position, the T will be inserted. And then U. Then U will be inserted here. Now the T Q is full. The Q is overfull. We cannot insert any more elements inside this queue. That means we can't insert this V inside this. We can't insert this V inside this queue anymore because the queue is overflowed. So this will be our current queue condition for this particular question. There often a theory type question comes like this. Write an algorithm to reverse a single linked list. We will be studying about linked list in more details in our next upcoming videos. Stay tuned for that. But for last minute study purpose, this note is very important. Please go through this note and study each and every points of these type of questions and make sure you remember this for your examination purpose. Specifically for MAKAUT third sem DSA students and BCA, BBA and CSIT students. Take a screenshot and go through it very carefully. The next question is write an algorithm to insert a node at any position in circular linked list. These are the steps in our algorithm for inserting any node at any position inside a linked list. And the next question is take a screenshot first. The next question is the difference between static memory allocation and dynamic memory allocation. So static memory allocation is when the memory is allocated while the compile time. At the compile time, which memory is allocated? That is called static memory allocation. And at the runtime, that memory is allocated is called as the dynamic memory allocation. The difference between malloc and calloc function. This is also a very important questions for MAKAUT semester examination. There often also a question comes like find the time complexity of binary search. So you have to memorize these function. You have to memorize this function for calculating the binary search time complexity. And here that this is Tn is equal to Tn by 2 plus 1. Here let me say one thing, that is when it comes binary search or merge sort, always the time complexity is bigger of log n or n log n. Just memorize it like this. When a array is divided into two parts, when the whole array is divided into two even parts, then like the whole array is there and evenly it is divided into two parts, then always the time complexity will be in the terms of log n. Like for binary search, it is log n. For merge sort, it is big O of n log n. Kindly memorize it for your exam. This is also very important for MCQ type question purpose, and also like finding out the time complexity. One thing you should remember for MAKAUT examination, that is if you forgot to if you forgot how to find out the time complexity step by steps, you could just write the time complexity. It will help you to have some part marks uh, for this question. So here, this is the function we have to memorize, and we have to divide n by 2. So Tn by 2 means here Tn by 2 by 2. I think I should take a separate video for finding out the time complexity of binary search, because this is already getting so big and so large, and I am also so tired. So if that's okay, we will be taking another class for finding out time complexity of binary search, insertion sort, merge sort, like this type of questions that often comes in MAKAUT semester exam. So let this like this. Let's come to the next question, that is binary search algorithm step by step procedure. Here I am taking array, and with the help of this example array, we will learn about the algorithm about binary search. So here our question is, we have to find out the element 55. We have to search the element 55, and we have taken a variable that is x, and we stored this 55, this number inside this x variable. We take this LB, that means lower boundary is equal to 0 and upper boundary is equal to 30. You can say, oh, there are 14 elements present inside this array. There are total 14 elements inside this array, and this is 0th index, this is 13th index. So the lower boundary is 0 and the upper boundary is 13. So the first step is, there is a if condition, that is 13 less than 0. That means if the upper boundary less than the lower boundary, if this condition become false, then we have to perform this operation, that is mid is equal to lower boundary plus upper boundary minus lower boundary by 2. That means we have to find out the middle position, because for binary search, the array is divided into evenly two parts. So we have to find the mid position. For mid position, we have to uh, do this formula and find this mid position. If this condition become false, then only we enter in this situation. If the array is if the array 6 index, that means if the middle array of middle position is our required element or our searching elements, then it will definitely show me the output. But if it is not, then it will again we will increase the lower boundary from 6 to 7. Sorry, not we will not increase the lower boundary, but we will mark the lower boundary at the seventh position. That means mid plus one position. For the step two, when the lower boundary, upper boundary less than lower boundary, this condition become false, then we again find out the mid. And like this, recursively, this condition will run to find the to find our ultimate solution. If we what element we are trying to find. Take a screenshot and try to understand by yourself. This is nothing. This is very easy, and binary search is the most easiest search in the data structure. If you just look closely, you can understand each and every steps. Uh, okay, so thank you and stay tuned for the next video. And if you like my contents, please do like, share, and if you are facing any problem while understanding any topic, feel free to comment uh, below the comment section. And thank you.